Hello everyone, Shahin is here. Today I'm going to demonstrate a feature inside Canvas quiz which is quite helpful for online assessment. The problem we have is in a final exam. It's very difficult to invigilate students, and once they are doing the online test, there is a possibility that they can communicate through other means such as mobile phones, and if they share their answers together, that would be a disaster. I mean, one suggestion was to create a question bank, and from that question bank, each student is getting a different questions, or they are allocated questions by random. But that can be argued that the questions might not have the same difficulty, so students always can complain about that. But the use of the Canvas feature would overcome this problem. The first thing we need, before I show you the Canvas and how this can be implemented, you need a problem which is solved parametrically. In my case, this is a structural mechanics, and here I have a beam which is subjected to a distributed load, and I know for the fact the maximum stress due to the bending is taking place at C, and that normal stress in a parametric sense, I have the answer, the solution. That's W0 L squared divided by 1.5 A cubed, in which L is the total length of the beam, A is the cross-sectional rectangular cross-section of the beam, and W0 is a triangular distributed load. So how I have to slightly change this question in my Canvas, and I've already done that, so quickly I get you through how this can be set. It's very easy, and I'm sure you will find this useful for setting up your major assessment task. So here I call a new quiz called randomized question using formula, and in this question I show you the output first. So if I try preview, that is the same question, not parametric. So I mean, the shape, the illustration has everything with parameter, but inside the problem I have the random assigned numbers. So here, for a certain given geometry L, A, W0, the students are supposed to find the maximum stress in megapascal. And so what do they get is a box here to fill in. So I know for the fact the solution is L squared. So let's calculate this. That's 287 squared and multiplied by W0. W0 in this case, that is 440, and that divided by 1.5 times A. In this case, that is 70 millimeter. So entire thing cubed, and the final answer is 33 point something. I'm copying and pasting this from my calculator and putting that here. I mean, how to get to this stage? That's not a simple formula. I mean, students have to do the shear force diagram first, and then doing the bending moment diagram, and then find the maximum. In the maximum, they find out the maximum normal stress is either at the top fiber or lower fiber. So quite a number of steps, but that is the final answer, right? So when I submit this one, look what happened. So I get no complaint from Canvas. This indicates that my answer is correct, right? So now I'm going to show you how this was done. I go to editing the quiz, and here at the programming level, I mean, it's hardly can be called programming. It's a simple thing. I mean, everything here is text, and I have 3 parameters. The first one I call this W, the second one, the first one call it L, second one A, and third one W. So my parameters are placed inside a square bracket, so you see in front of them these are the units. And once you do that, the question category have to be changed into formula question. And when you select the formula question, what do you get at the here? You have three parameters L, A, W, each of which giving the feasible range for the variations. Decimal point, I mean, you can change the decimal point to something you want, but in my case that doesn't make sense much. I kept them to 0. And then here I have to write my formula. So that is when the parametric solution comes handy. So I go to my parametric solution, that is my formula. So W times L squared divided by 1.5A cubed. And I'm just using a simple math script to create that formula. So again, my resulted value can be reported by number of decimal point. In this case, I don't need any decimal point because all my values were perfect numbers with no decimal point. And then in my class I have 40 students, so I'm changing that to offer 40 different combinations. And then in many cases, say that the gravitational acceleration could be taken at 9.8, 10. I mean, these cases would make some room for margin of error. In this case, 2% could be enough. You can increase it if you wish. And when you press generate, there are going to be 40 different sets with the acceptance margin developed. And that is in front of the comment answer. I put a comment. So this can be edited later on, putting pictures, symbols, equation, anything you need. So now I'm done, and you notice that this question by itself would be randomized, but that I prefer to keep it inside a question bank. So that question bank later on would let me to reuse the question, or if I want to assign a set of question from my question bank randomly to students, that can be done. But here we want to give the same question with different values to make that cheating proof. And once I update and save my quiz, right, so everything is ready. From question perspective, what they see is a question with some set values, and from the marker perspective, I mean, they don't have to go to an extensive marking scheme. Of course, later on, if you want to give scores for the steps between the beginning and the final answer, you can add an upload option at the end of your quiz. So thank you for watching this video. Please let me know if you have any question. I'll be more than happy to help. Thank you.